On the 9th of April 2026, a 10-year-old girl sent a letter to NASA asking to make Pluto a planet again. And what's surprising is that they agreed. NASA Administrator Jared Isaacman said that they were looking into reinstating Pluto's full planet status. Before you get too excited though, NASA does not get final say on the matter. That's the responsibility of the International Astronomical Union, the organization that demoted Pluto to dwarf planet status in the first place. But what is evident is that for many, the debate still rages on. There are few places in our solar system that evoke stronger emotions than Pluto.
What is it about this dwarf planet that continues to capture our hearts and imagination?
And why have the arguments around Pluto's planetary status suddenly come back to the fore? Could there really be a chance that one day, as Isaacman hopes, Pluto may be a planet once again? I'm Alex McColgan and you're watching Astrum. And in today's Supercut, we return once more to Pluto to learn more about this incredible celestial object. We'll discover why it was demoted 20 years ago and reveal the obstacle that stands between Pluto and its former glory. Perhaps one of the things that makes Pluto so fascinating is the sense of mystery surrounding it. After all, this was once considered our furthest away planet, existing 5.9 billion kilometers from the Sun on average. And since we first spotted Pluto in 1930, there has only been one mission to explore this tiny object, New Horizons. So let's take a closer look at what the New Horizons probe found, and witness some of the wonders that can be discovered on this distant, enigmatic dwarf planet.
New Horizons launched in January 2006 from Cape Canaveral Air Force Station. Its primary mission was to photograph and collect information on Pluto and its moons Charon, Styx and Nix, not to mention Kerberos and Hydra, which hadn't been discovered yet. On the 14th of July 2015, 9 years into its mission, New Horizons made its closest approach to Pluto, capturing a breathtaking glimpse of its surface that exceeded our wildest imaginings. Ice mountains, nitrogen glaciers, cryovolcanoes, and canyons. But given the immense distances involved, transmission was limited to just 1 to 2 kilobytes per second. It took 15 months to downlink the full dataset, which caused a sensation every time NASA released a new image. As I look at these images today, my sense of wonder hasn't dimmed. There's so much information to unpack. It feels a bit like working on a puzzle. And like any good puzzle, the fuller picture only reveals itself after you've taken the time to piece it together. Let's start with a unique feature called the brass knuckles, located near Pluto's equator. It is comprised of 6 lowland regions, called Maculae, with an average width of 480 kilometers, each roughly the size of Iceland. If we take a closer look, we can see that they are interlaced with a network of canyons. From west to east, they are Crun, Alla, Balrog, Vukabkame, Hunkame, and Mengpo. Each of these names come from a different netherworld spirit from world mythology. So, for those Lord of the Rings fans watching, you'll be excited to know that Balrog Macula is a reference to that wizard battling demon of Middle-earth. We think the brass knuckles get their dark colour from a tar made of tholins, which are hydrocarbons formed from the interaction of methane and nitrogen with cosmic rays. Tholins are in abundance throughout Pluto, such as here, in the neighbouring whale-shaped region known as Cthulhu Macula. The reason the brass knuckles appear separate is that each macula is divided by towering uplands covered in ice. These uplands stand several kilometers tall and are likely made of frozen nitrogen, methane, and carbon monoxide on top of a bedrock of water ice. On Pluto, water ice is strong enough to form mountains because of its low gravity. Nitrogen ice, however, is much softer, which is why it tends to flood the lowlands on Pluto. One can only imagine what these colossal ice mountains must look like from the canyon's perspective. Nitrogen is the most common material on Pluto's surface, 98% of it in fact. Nitrogen ice also accounts for a large part of Pluto's most iconic feature, its heart-shaped region known as Tomba Regio, named after Pluto's discoverer Clyde Tomba. The western lobe of the heart is a smooth basin filled with nitrogen ice called Sputnik Planitia, while the eastern lobe is much rougher. In this image you can see the relief in remarkable detail. Scanning from west to east, you can almost feel the difference with your fingertips. The eastern side looks pitted, like an orange's skin. Scientists think Pluto's winds are carrying nitrogen from Sputnik Planitia up into the atmosphere and depositing it back into these eastern uplands, which is why their albedo is so high, albedo being the measurement of how much light a surface reflects. Notice how the uplands have a bright, icy sheen due to all the nitrogen ice deposited there. We think that some of that nitrogen, in turn, slides back into the lowlands via glacial flow, meaning the western and eastern halves of the heart have a transactional relationship. It's an unusual arrangement, but who are we to judge?
Unfortunately, being so small, you can't see details like this from Earth. In fact, the entire dwarf planet isn't visible with the naked eye. But if you want to find any of the other planets in our solar system, or you've got a really powerful telescope, then what you really need is Oranos, an all-in-one platform for astronomers. It takes the stress out of planning your stargazing sessions so you can instead focus on enjoying the wonders of the cosmos. With this app, literally everything is in one place. A 14-day forecast based on your location allows you to pick the perfect day for viewing, and the Sky Quality Index analyzes conditions every 15 minutes, taking into account cloud coverage, visibility, and other weather conditions to make sure that you never miss the perfect stargazing slot. What I really love is that it doesn't have to be just when you're at home. Their maps are global, and the automatic weather model selection means you're always getting the most accurate data even when you're taking a trip. Oranos' sky analysis tool shows you when planets, deep sky objects, and comets are observable, with hourly altitude updates so you can even make yourself a viewing schedule. It can even help you with the best dark sky spots thanks to light pollution maps and locations shared by the community. And that's what I love best. Just like Astrum, Oranos is a community with an area to upload your best photos and generally enjoy the wondrous space with others. You can join today with a 7-day free trial for Astrum viewers, and for a limited time, 30% off an annual subscription. Just click the link in the description to get your web, Android, or iOS version of this essential stargazing tool. For now though, let's look at another of Pluto's spectacular landscape features.
Over on the western side of Sputnik Planitia is a towering mountain range called Al-Idrisi Mons. Here, the winds blow tiny particles of methane ice towards the mountains and deposit them back onto the surface like grains of sand. This is remarkable in itself, since Pluto's atmosphere is very thin. We didn't expect its winds to be capable of this kind of transport. Most likely, these methane particles are uplifted by sublimating nitrogen ice, a process which a substance changes phase from solid to gas. We think the sublimating nitrogen rips tiny grain-sized particles of methane ice, which carry up into the atmosphere and settle closer to the mountains. These methane deposits form a vast 2,000 square kilometer field made of transverse dunes, somewhat resembling those in China's Taklamakan Desert or California's Death Valley. But unlike those deserts here on Earth, these dunes form in frigid temperatures of -230 degrees Celsius. The tiny grains of methane that form the dunes are much lighter than sand, and in Pluto's low gravity would likely feel like dust spilling through your fingertips. However, given the -230 degree temperatures, I wouldn't recommend trying. The dunes aren't the only item of interest in this corner of Sputnik Planitia. On the western side of the mountains is a deep trench, which you can see as the dark blue band on this colorized elevation map. Based on our measurements, the peaks adjacent to the trench vary from 200 meters to 1 kilometer in height, while the furthest peaks are much higher, reaching 3 kilometers in height, nearly as tall as the Rocky Mountains. This means the mountains get taller as you move further from the trench. Why is this significant? Well, we think it might be connected to what's going on underneath Pluto's surface. You see, one of the most fascinating revelations we've recently made about Pluto is that it may have had, and might still have, a vast subsurface ocean. This is a characteristic it would share with several moons in our solar system, such as Ganymede, Europa, and Enceladus. The fact that Pluto could host liquid water at all is remarkable when you consider how far away it is from the Sun. It would have to generate significant heat from nuclear decay in its core, yet Pluto is smaller than our own moon. Given the diminutive size of its core, you wouldn't expect it to generate a lot of heat, so the evidence for a subsurface ocean took a lot of people by surprise. This is very interesting, but I'm sure you're wondering what it has to do with the mountains we just looked at. Well, a 2019 study published at the Lunar and Planetary Science Conference argues that the Al-Idrisi Mountains have very likely moved east through solid-state convection. This movement could have produced both the deep trench on the mountain's western side, as well as the uplift we see in the rising peak elevations moving from west to east. If this theory is true, these dynamic processes happening on Pluto's surface would seemingly support the idea that there is a layer of liquid water beneath its icy crust. We see other evidence as well, in the form of cryovolcanoes. Right Mons is one potential cryovolcano we've looked at previously on this channel, but here it is in the highest resolution color view that the New Horizons team assembled. What you're seeing is a composite of images taken by the probe's LORRI camera and its RALPH multispectral visible imaging camera. Right Mons is a massive structure made mostly of water ice, standing 4 kilometers tall, with a gaping depression in the middle. And it may have been active fairly recently, as evidenced by the lack of impact craters in the surrounding area. Scientists spotted another potential cryovolcano to its southwest called Picard Mons, and it's even more massive, rising 7 kilometers tall. Sadly, it was already in darkness by the time New Horizons was able to capture it, so the images aren't quite as clear as those of Right Mons, but you can see it here in this colorized topographic map. It too has a huge depression in its center. The depressions of both structures are reminiscent of cauldrons we see here on Earth, but they are much larger relative to the size of the volcanoes. Looking closely, there appear to be concentric rings surrounding the depressions, indicating, perhaps, a series of eruptions followed by a retreat of magma and subsequent collapse of the vents. Just to be clear, we haven't yet confirmed that these are definitely cryovolcanoes, but the literal mountain of evidence is hard to deny. From all of this, it is clear that Pluto is a fascinating, beautiful place. Hopefully you now feel like you know it a little better. But none of this answers one key question. Is it deserving of being a planet? The key to that question, and why Pluto stopped being a planet in the first place, all started in 1978 with one key discovery. It's time to talk about Charon. The story of Charon begins not with a deliberate search, but with a mistake. On the 22nd of June, 1978, James Christie, an astronomer at the US Naval Observatory, was performing a routine but tedious task, examining photographic plates of Pluto to refine calculations of its orbit around the Sun. The images, taken with the 1.5 meter Kaj Strand telescope in Arizona, were not considered high quality. In fact, several plates had been marked as poor or defective because they showed Pluto not as a clean, sharp dot, but as a strangely elongated blob with a distinct bulge on one side. To most, this would have been an annoyance, an imperfection to be discarded. Atmospheric turbulence or improper telescope alignment could easily cause such distortions. But Christie had a specific background that prepared him to see something others had missed. He spent years photographing double stars, and his trained eye recognized a familiar pattern in the strange bulge. He noticed a critical detail. While Pluto's image was smeared, the distant background stars on the very same plates were perfect, sharp points of light. If the problem were with the telescope or the atmosphere, everything in the image would be distorted. The fact that only Pluto was affected meant the bulge had to be real. There was something else there. Christie began a deep dive into the observatory's archives, unearthing plates of Pluto from as far back as 1965. Many of these too had been dismissed as flawed, bearing notes like Pluto image elongated. But now these failures became the key to confirmation. Christie saw that the bulge systematically moved around Pluto over time. He and his colleague, Robert Harrington, meticulously tracked its position across the years of archived images. They calculated that the bulge circled Pluto once every 6.4 days, a significant number because it perfectly matched Pluto's own known rotation period. This was the final piece of the puzzle. The ghost on the photographic plate was a massive companion, a moon locked in a synchronous dance with its parent world. With the discovery confirmed, the new moon was provisionally designated S1978 P1. As the discoverer, Christie had the right to propose a name. He chose to name the new moon after his wife, Charlene, whose nickname was Shah. Inspired by his interest in physics, where particles like protons and electrons often end in "on," he added the suffix to create Charon. It was a personal tribute, but by an almost unbelievable coincidence, it was also a perfect mythological fit. Only after proposing the name did Christie learn that in Greek mythology, Charon was a silent, spectral ferryman who carried the souls of the dead across the river Acheron into the underworld, the realm ruled by the god Pluto. The name was officially adopted by the International Astronomical Union in 1986. But this newfound moon was far more than just a companion. Its very existence would force a complete re-evaluation of the entire solar system, and in doing so would help topple Pluto from its planetary throne. The discovery of Charon immediately began to unravel Pluto's mysteries, and the first revelation was a profound one. By tracking Charon's orbit, astronomers could finally apply Kepler's law to calculate the mass of the system for the first time. The result was shocking. Pluto was not a small terrestrial planet, as some had thought, but was incredibly lightweight, about a sixth of the mass of Earth's moon. Charon itself was found to possess a substantial 12% of Pluto's mass, a ratio far greater than any other major moon in the solar system. Earth's moon, by comparison, is only about 1.2% of Earth's mass. This startling parity in size gives rise to a unique dynamic that sets the pair apart from every other planet-moon system. When a small moon orbits a large planet, the center of their combined mass, or the barycenter, lies deep within the planet. The moon makes a large orbit around this point, while the planet makes a tiny wobble. But Pluto and Charon are so close in mass that their barycenter lies in the empty space between them, approximately 960 kilometers above Pluto's surface. Pluto and Charon perform a perpetual dance around a common, invisible point in space, and that has implications. Our moon is tidally locked to Earth. That means it rotates on its axis in the same amount of time it takes to orbit us, which is why it always presents the same face to us. From the moon's surface, however, an astronaut would see Earth rotate, going through a full day-night cycle. The Pluto-Charon system is an extreme example of what is called mutual tidal locking. Not only does Charon always show the same face to Pluto, but Pluto always shows the same face to Charon. If you were standing on the Charon-facing side of Pluto, the great moon would hang motionless in the sky, a colossal disk that never rises or sets. If you were on the opposite hemisphere, you would never know it was there at all. They are locked in an eternal stare down across 19,640 kilometers of space. These two facts, the external barycenter and the mutual tidal lock, led many scientists to argue that the system shouldn't be considered a planet and a moon, but rather a double planet. This ambiguity became a central exhibit in the heated debate over planetary definitions in the early 2000s. The discovery of Charon provided the critical data, Pluto's low mass and the system's strange dynamics, that forced astronomers to confront the fact that the solar system was more complex than our simple categories allowed. The International Astronomical Union even formally considered a proposal to classify Pluto and Charon as a double planet in 2006, though the idea was ultimately set aside amidst the larger, more controversial decision to reclassify Pluto as a dwarf planet instead.
So, how did that happen? Prior to 2006, the term planet was used fairly loosely to refer to large objects in our solar system and beyond, a term rooted in traditions that predated our modern understanding of the universe. But while astronomers were gaining a greater appreciation for just how sizable Charon was compared to Pluto, they were also discovering other objects out beyond the orbit of Neptune: Quaoar, Sedna, Makemake, and Eris. Of these, at the time, Eris was thought to be larger than Pluto, although more exact measurements since then have found it to be slightly smaller, at 2,326 kilometers in diameter at its equator compared to Pluto's 2,377 kilometers. Still, it is more massive. So if Pluto was a planet, were these planets too? This question caused the International Astronomical Union to convene and come up with a new definition of a planet, one that could remove all the confusion. And it laid out 3 key criteria that a planet had to meet. 1. A planet had to orbit the Sun. 2. It had to have enough mass for its gravity to form it into a roughly round shape. And 3. It had to clear the neighborhood around its orbit. It was the last criterion that was the fatal blow for Pluto as a planet, because while Pluto has managed to form into a roughly round shape and does orbit our Sun, its tiny mass had not been enough to clear out its orbit of thousands of other large objects, like the Plutinos, Orcus, or Lempo. While finding Charon had not been the final nail in Pluto's coffin as a fully fledged planet, its discovery was a key domino in a cascade that led to Pluto's eventual demotion. Its fascinating gravitational dance with Pluto has linked it inextricably to the dwarf planet, and 2006 was not the first time it had a massive impact on the dwarf planet's history.
So, how did such a strange system come to be? For many years, the leading theory for the formation of the Pluto-Charon system was a scaled-down version of how our own moon was born, the giant impact hypothesis. In this scenario, a massive Kuiper belt object slammed into a proto-Pluto in a cataclysmic collision. The impact would have blasted a huge cloud of debris into orbit, which then gradually coalesced to form Charon. This model successfully explains the system's high angular momentum and Charon's nearly circular orbit. However, as our understanding of planetary materials and our computational power grew, this model started to show cracks. Pluto and Charon are not molten bodies of rock like early Earth. They are small, rigid worlds made of rock and a great deal of water ice. These materials behave very differently under the stress of a cosmic collision. More recent and sophisticated simulations have given rise to a new, more elegant theory. This model proposes a much lower velocity grazing impact, less of a planetary shattering and more of a cosmic kiss. Instead of obliterating each other, the Proto-Pluto and Proto-Charon collided gently enough that they became temporarily stuck together, spinning through space as a single snowman-shaped object for a few hours before tidal forces pulled them apart again. They separated, but not completely, remaining forever bound by gravity in the binary system we see today. This kiss and capture scenario has a powerful advantage over the giant impact model. It explains how both bodies could have survived the encounter largely intact, preserving much of their original internal structure and composition. This aligns perfectly with observations that show Pluto is denser and more rock-rich, about 70% rock, than Charon, which is only about 55% rock, suggesting they formed as separate bodies that were not thoroughly mixed together in a fiery collision. Crucially, this formation story does more than just explain the system's orbit and composition. It provides the key to understanding Charon's entire geological history. The initial impact and, more importantly, the immense tidal friction generated as the two bodies stretched and pulled on each other during their separation would have deposited a tremendous amount of heat deep inside both worlds. This injected energy is the starter pistol that fired off Charon's geological evolution. Trapped beneath a crust of ice, this heat would melt the interior, creating a subsurface ocean and setting the stage for the planetary scale drama that would later unfold across its surface. For 37 years after its discovery, Charon remained little more than a fuzzy companion to Pluto. But on the 14th of July 2015, NASA's New Horizons spacecraft flew past the binary pair, transforming them from distant points of light into vibrant, complex worlds. The images New Horizons sent back from Charon were stunning. They revealed a world that had, at some point in its distant past, torn itself apart. Charon's surface isn't smooth. It's dominated by a system of vast tectonic faults, enormous ridges, towering cliffs, and deep valleys that scar its surface. The most spectacular of these is a great belt of chasms that wraps around the moon's equator. This system, which includes the informally named Serenity Chasma, runs for at least 1,800 kilometers and plunges to depths of up to 7.5 kilometers. To put that in perspective, it's more than 4 times as long and nearly 5 times as deep as Earth's Grand Canyon. These are not canyons carved by rivers, but colossal pull-apart faults, evidence that the entire crust of Charon was once stretched to its breaking point. What immense force could cause a whole world to expand and rupture? The answer lies with the heat from its formation. That initial energy, supplemented by the slow decay of radioactive elements in its rocky core, was likely enough to melt the water ice deep inside Charon, creating a vast, liquid water ocean beneath a solid, frozen crust. For a time, Charon was an ocean world. But all small bodies in the outer solar system eventually lose their primordial heat to space. As Charon cooled over millions of years, this subsurface ocean began to freeze. Here, a peculiar property of water becomes critically important. Unlike most substances, which contract when they freeze, water expands. As the ocean turned to ice, its volume increased, pushing relentlessly outwards on the brittle, overlying crust from below. The surface stretched and strained until it could hold no longer. The crust of Charon ruptured, creating vast canyon systems that still span the dwarf planet today. As one scientist put it, Charon tore itself apart at the seams, like Bruce Banner becoming the Hulk. Today, Charon appears to be geologically inert. Its period of great upheaval is long past. Because it lacks a thick atmosphere or ongoing geological activity to erode or bury these features, the evidence of this ancient cataclysm is well preserved. The surface of Charon is not just a landscape, it's a frozen snapshot of the death of its ocean. The freezing of Charon's ocean did more than just break its crust. It also paved over half the world. The New Horizons images revealed a tale of 2 hemispheres with dramatically different stories. The Northern Hemisphere, informally named Oz Terra, is an ancient, battered world with rugged, high-standing terrain, heavily cratered and crisscrossed by the vast network of tectonic faults and canyons created by the expanding interior. This is the original crust of Charon, frozen in its fractured state. But to the south, the landscape transforms. This is Vulcan Planitia, a vast, smooth plain that's starkly different from the tortured lands of the north. This region is far less cratered, indicating that it is a much younger surface. It sits at a lower elevation than Oz Terra, and its surface is marked by features that look like frozen flows and broad swells. Scientists believe Vulcan Planitia is one of the most extensive examples of cryovolcanism in the solar system. These weren't volcanoes of molten rock, but icy slush. As the subsurface ocean froze, the expansion not only cracked the crust, but also pressurized the liquid water below, which was likely mixed with ammonia that acted as a sort of antifreeze. This pressurized cryomagma was forced upward through the newly formed cracks and fissures, erupting onto the surface. Icy lava flooded the southern hemisphere, creating the smooth, young plains of Vulcan Planum. Scattered across these plains are several large, isolated mountains such as Kubrick Mons, which appear to sit in strange depressions or moats. These may be colossal blocks of the older northern crust that broke off, were carried along like icebergs on the cryovolcanic flows, and left stranded as the plains froze solid around them. Perhaps the most visually arresting and mysterious feature on Charon is its North Pole. Capping the top of the moon is a large, dark, reddish-brown stain, a feature so prominent that the New Horizons team informally named it Mordor Macula, after the Black Land from The Lord of the Rings. The color is almost certainly caused by a class of complex organic molecules called tholins,
the same ones we saw on Pluto earlier.
Tholins are common in the outer solar system, but their concentration at Charon's pole is unique. The key to understanding why they are here is to find the source of the methane. There are two competing theories. The leading hypothesis is that the methane is a gift from Pluto and its atmosphere rich in nitrogen and methane that's slowly escaping into space. As Charon orbits, its gravity captures some of this lost gas. During Charon's long, dark polar winter, which lasts for more than a century, temperatures plummet to below minus 240 degrees Celsius. At these extreme temperatures, the captured methane freezes directly onto the surface in a process known as cold trapping. When the pole finally swings back into sunlight, the accumulated methane ice is bombarded with UV radiation, which cooks it into the reddish tholins that stain the pole. Charon and Pluto are then a dynamic, interconnected system, with one world actively painting the surface of its companion across thousands of kilometers of space. But a competing theory suggests the methane was an inside job, that it originated from Charon's own interior. The massive cryovolcanic eruptions that formed Vulcan Planitia would have also released enormous quantities of gas, including methane, that were dissolved in the subsurface ocean. This would have created a temporary atmosphere on Charon, and just as in the first hypothesis, methane would have migrated to the coldest parts of the moon, the poles, and frozen out. Over billions of years, this native methane deposit was then irradiated to form Mordor Macula. This theory elegantly ties the origin of the polar cap directly to the other major geological events that shaped the moon. Whether the methane came from Pluto's atmosphere or Charon's own interior, Mordor Macula is a visible testament to the inescapable connection between these two distant worlds, a direct product of their shared history and environment. Charon's journey began with a smudge on a photographic plate that was nearly dismissed as an error. It ends with a complex and dramatic world. A world of continents spanning canyons deeper than any on Earth, vast plains of ancient ice lava, and a mysterious red stained pole. It's impossible to tell the story of Pluto without Charon. It was Charon's orbit that gave us the first true measure of Pluto's mass, revealing it as the king of a new class of worlds. It was Charon's existence that pointed to a shared, violent birth that sculpted both bodies and ejected them with the heat that would fuel their evolution. It's Charon's fractured surface that tells a story of a lost ocean, a geological history that provides a crucial context for understanding the forces that may still be churning deep inside the more active Pluto today. And it's Charon's red pole that may serve as a permanent record of Pluto's atmosphere, bleeding out into space over the eons.
There is one final point I want to consider in our story of Charon and Pluto. The discovery of this tidally locked neighbour might have started the process that saw Pluto relegated to the position of largest of the dwarf planets, but will that always be the case? Will Pluto one day regain its position as a full planet in spite of its strange relationship with its similarly sized moon? There are some grounds to think so. Setting aside letters from 10-year-old girls to NASA administrators, there were a lot of pleases in that letter, to be fair. There is something a little off about the current definition of a planet. To be a planet, an object needs to have cleared its neighborhood, the orbital track around the sun that the would-be planet traverses. But there are 10,000 asteroids near the Earth, and 100,000 Trojan asteroids in Jupiter's orbit. Strictly speaking, if Pluto failed its definition on this count, shouldn't we? Shouldn't Jupiter? Now we've seen the rich and complex geological processes that take place across Pluto's surface, there are some scientists who believe that this complexity should be taken into consideration when deciding whether something is a planet or not. They argue it should take precedence over the requirement that the planet should have cleared out its orbit. So, with the administrator of NASA seemingly in favor of the idea, it's possible that scientists may one day revisit the definition. After all, the only thing that truly makes an object a planet is enough people agreeing that it is. The term planet is entirely a human definition, and if we decide that we want to redefine it based on new information or considerations, there's no reason why that couldn't happen again. It's happened once, after all. So it will be very interesting to see what Isaac Munn meant by "we're looking into this." But whether it's a planet or not, Pluto will continue drawing our fascination, our curiosity, and our awe. A rose by any other name will still smell as sweet after all. Apparently, the same thing goes for the beauty and charm of the place we call Pluto.
There's a reason these educational mini-documentaries are free for everyone. It's not just the ads or sponsors, but it's thanks to our hundreds of Patreon members who make it possible for everyone to get the best possible content. They are the foundation that keeps Astrum steady and focused on quality over clicks. Every video you watch exists because there's a community behind it that values learning and curiosity. If you'd like to be part of that group, the people who keep space education open to everyone, join us on Patreon through the link below. We would love to have you.